this integral, it does not look very simple. Now let me do two methods for this integral. Method 1, I first withdraw x, cosine x out. So after draw out of the bracket, becomes square. It becomes cosine square x, and becomes 1 minus x tangent x square, right? Okay. And the numerator is the same, x plus sine x cosine x and dx. Then I simplify by bring the cosine square out to the numerator. This is 1 plus x tangent x square, and this becomes x. 1 over x square, tangent square is a secant square x, plus 1 over cosines cancel with the other sign, becomes tangent, right? Dx. Good. And do you find that the derivative of the denominator is equal to the numerator? So something like that. You see, d 1 over star is equal to negative, right? This square and d this. Is this correct? Yes. Now, okay. So, our rational function could become d 1 plus x tangent x, right? This derivative becomes this is square, right? And on top will be the derivative of this one. This derivative is 1 times this one secant. Okay? And multiply by this derivative, which is 1 times tangent. So it becomes negative, which is a negative outside. Right? Wait a minute. Is this negative? It's negative, right? I'm sorry. This is negative. I copied positive. Now this is a negative. If it's negative, then this derivative will become positive. See, positive again. So that will be. I'm sorry, there's an error for the sign. So this one becomes 1 minus tangent x plus c. That's the end of it by method of 1. Okay. Yeah. Okay. I don't want to repeat that there's an error here because this derivative is negative plus the negative required in the rational function derivative, so it becomes positive again. Now this is method of 1. Method 2, x plus sine x cosine x dx, and the cosine x minus x sine x squared. Okay, good. Now the second method, I want to create something like a denominator so I can change in this, I can reduce the power of the denominator. So my denominator is a cosine x minus x sine x square, right? I want to have the same thing as denominator, so I must have this. Okay. Then plus or minus something to make same thing as given in numerator. But I tried this, it didn't work. But I tried negative, it works. Negative means negative cosine x minus sine times sine x. Well, I meant that I have this one, but not positive, negative. Then I consider balance with the numerator. This one time this one is negative sine and cosine. But I have positive sine and cosine. So I must have a 2 sine x cosine x. Well, I have a x here. I cannot omit that x. Then I have a positive x sine x square. I don't have. So I take x sine square x. Yeah. Now this is equal, right? Well, what is the technique of integration? Just changing the integrand until what we want reached. At the same time that you maintain an equal sign. That's called techniques of integration. Now I create this, but at the same time I want to balance the equal sign. Therefore it becomes this. Then I have an integral. I have two integrals. One cosine x minus x sine x square and 2 sine x cosine x. This I have a common factor x, and becomes 1 minus sine square, which is a cosine square, so it becomes x cosine square, right? I combine these two to become this, and this is first integral minus. Now I can reduce, right? That's what I want in the first place. Cosine x minus x sine x. Reduced power. On top will be sine x cosine x, right? Yeah. This is out there, sine x cosine x. Okay. This I keep as is, cosine x minus x sine x squared under 2 sine x cosine x plus x cosine square x dx minus this is a cosine x minus x sine x. Cosine x dx is a derivative of the cosine, negative, right? So it becomes d cosine x. Change the sign, right, for positive, because the cosine derivative is a negative sign. Now then, This one, well, let me copy it again. I don't want to omit something which is necessary. Okay, then there's 2 sine x cosine x plus x cosine x dx. Now then this one I can do by parts, right? This is 1 over this is u. Cosine is my v, right? dv. So it becomes uv cosine x minus sine x, x sine x, times v is this, minus v du. This is v, right? The cosine. du. du is this derivative, right? Is this derivative. This is my u, cosine x minus x sine x. This is my u. Now the second part of by parts becomes v du. This is v times du. du becomes this one square, right? Times the negative of this derivative, which is negative sine. And this derivative is negative sine again, negative x cosine x, right? Yeah. So it becomes this is square. This negative become plus negative 2 is 2 sine and plus x cosine x, right? So this is my du. This is my du. So let me copy down this one. Becomes cosine square plus minus sine x square, and on top will be 2 sine x plus x cosine x times x cosine x. 2 sine x plus x cosine x. Yeah. So to find that this is sine 2 sine cosine x plus x cosine square. That's that exactly equal to this. So this one is cancel with that. X cancel with that. So left cosine x minus x sine x plus c. And if you divide it by cosine, this is 1, this is 1 plus x. No. So divide by cosine, this is 1, this is 1 minus x tangent x plus c, right? That is the same result as in method 1. So, okay. That is the method 2. I suggest you just go over by yourself, go over again step by step, and you will find that it works very well. See, these 2 methods are all basic and very good for practicing the techniques of integrations. Thank you.